Hi, welcome back. In the last part, we looked at creating a heads-up display, which allowed us to select different objects that we might want to place in the world. In this part, we're going to be doing just that. We're going to be taking objects from our heads-up display and placing them in the world. The first thing we want to think about is how do we actually want to place these objects in the world, and under what conditions. So one of the first conditions is we don't want to be able to place these objects outside of the world, outside of this kind of world grid. We also don't want to be able to place objects on one of the panels. We don't want to place an object on top of an existing object, like these two rocks. And also, very importantly, we want to be able to place these objects so that they fit into the grid, just like these rocks or these trees. We don't want any kind of free positioning. That will be very important for many things that come later. But yeah, so this is what we'll be doing right now. So what we'll be doing now is adding some of these constraints for how we want to add objects into the world. Because we'll be dealing with adding things directly to the world, we're going to be writing all of this logic into the world class. So first opening up the world class, but also what we want is for our world class to communicate with our HUD class, because it's the HUD class that is actually managing the tile that we select, but we want to let the world know which tile is selected. So to do this, inside our world class definition, we can add HUD as an argument, and we're going to save the HUD inside of the class, like this. Also, because we want our world to update in real time as the game updates, we're going to be giving the world class an update and a draw method. So if I quickly write these in as placeholders for now. So just passing for the update, and we'll add in a draw. And actually what I will do is we will move all of this draw logic, because it's basically just drawing different elements of the world. So to kind of help better organize our code, we can take all this and move it inside of world. So I'm just going to paste it here. We're going to need to fix this slightly. So one of the things we'll need is the screen, and so this will just become screen. This is no longer self.world because we are in the world class. So we just need to remove this dot world in several places. The other thing that we need when drawing is the camera scroll. So we will add camera as an argument as well. So I'm just going to quickly go through this code and fix it, and it's a good opportunity to get rid of the unwanted comments. So again, this is going to be removing .world, same here, same here. So then, now that's all been cleaned up, we can go back to our game class and just write in self.world.draw, and we need to pass it the screen and the camera. So already now it's quite nice always to clean up the game class and keep it as minimal as possible. The other thing that we need to update here is we want to pass the HUD into the world. So I'm going to pass it like this, but I'm just going to move now the HUD definition above the world so that we're able to do that. Running the game again, we just want to make sure that nothing's broken and everything works. Yeah, and we get exactly the same. Everything seems to be working fine. We've just reorganized some of the code. Now to check whether all of the constraints that I mentioned are satisfied, the key thing we need to do is understand which tile we are currently hovering over with our mouse, because that will help us answer all the questions like, are we outside of the grid? Are we on top of another object? Are we actually on an existing tile? So this is what we're going to be doing now. So if we return to the world class and scrolling to the bottom, I'm going to create a new method, and I'm going to call this mouse to grid. And it's almost going to be the reverse of this function. So here, when we went from kind of grid coordinates like grid x is 1, grid y is 2, and we transformed these into kind of isometric pixel coordinates, we're almost going to do the reverse of this, but we're going to go from the mouse's coordinate position and work all the way backwards to find out the grid positions of x and y. So using self, we want to pass this in x and y, which are going to come from the mouse coordinates. And then we're going to work through a series of calculations to get back to these grid values. So the first transformation we want to do is finding the world position. So our mouse might have coordinates 500 pixels x, 500 pixels y, but that has nothing to do with the world's position, because we've been using a camera scroll, we've been offsetting. This is the first calculation that we need to do. So transform to world position. And essentially this means removing camera scroll and offset. So we can say world x equals x minus scroll.x. So we also need to pass the scroll here. Because remember, when we were rendering, we were doing plus scroll x, so we need to do the reverse, which is minus. And then we need to take away the offset that we applied. And so if you remember that we applied this self.grass tiles, the width of the self.grass tiles over 2. So we will be minusing that. Then for the y, we take the y position of the mouse, and we just minus the scroll in the y. We didn't apply any offset in the y, so we can just leave that. Now that we have, why is it doing this? Now that we have the world positions, we need to remove the isometric transformation. So we're going back to Cartesian. So I'm going to say transform to cart, and I'm just going to make a note. This is the inverse of cart to iso. So we're going to undo the effect of this. So this transformation looks like this. So we can say cart y equals brackets 2 multiplied by world y, and this is just a formula, minus the world x divided by 2, and then for the Cartesian x, we have Cartesian y plus the world x. Finally, now we're back in our kind of Cartesian space after shifting the world appropriately. We want to go back to these grid coordinates. So transform to grid coordinates. And to do this, what we need to do is do an integer division by the tile size. And we want these to be integers. So I'm going to just enforce it like this. So, and we do the same thing for grid y. So this is cart y divided by the tile size. And these are the grid values that we can now start using to make sure all of the conditions are satisfied. So I'm just going to return this is a tuple, so grid X and grid Y. Now that we've written a function from moving from the mouse's coordinates to our grid system, we can update our temporary tile placement so that the object that we want to render always fits on the grid, so we'll have a better idea of how it will look like inside the game. To do this, we can go up to the update function, and we're going, well, actually first to the init method, and we're going to create a new variable called temp tile and just assign this to none. So just like the selected tile in the heads-up display. Then inside the update function, because we'll be using the mouse position to create tiles in the world, we're going to go mousepos equals pg.mouse.getPos. And we want to query whether the user has, or the player has selected any object from the heads-up display. So we can do if self.hud.selectedTile is not none, i.e. they have selected something, then we can calculate the grid position based off the mouse's position. So I'm going to say gridPos equals self.mouse to grid, and we're going to use the mouse position arguments here. So mousepos 0, and that's the X, and mousepos 1 is the Y, and we need to apply this camera scroll. So I'm going to put in camera.scroll here, and so when we add this world update into the game class, we need to remember to pass the camera through this update method. So now having the grid position, we can start to extract the correct render positions and the image we want to render, and see how it looks like in the game. So we can, from this HUD.selectedTile, this is a dictionary which contains one of the elements that it contains is an image. So I'm going to say self.hud.selectedTile, and the element we're looking for is called image. And I'm going to make a copy of this because it's just going to be temporary. And like in the previous part, I'm going to set an alpha value here, just to make it obvious that this is just a temporary tile in our game. Now, for knowing where to correctly render this so that it fits within the tile, what we're going to do is we're going to use the world variable, or this world object that we created when we first made this class, because this contains all the information about our tiles. So if we have the grid position of a tile, we can extract all the information we want from this self.world. So the first thing that we're going to extract is the render position, and we can do self.world, and then using these grid coordinates, so gridpos 0, which is the X, and gridpos 1, which is the Y, and just scrolling down to look at our dictionary again, the element that we want is this render pos. So that's what we're going to put in here. So render pos goes here. And now that we've selected a tile and found the grid position, we're going to update this self.tempTile to also be a dictionary, and we can say the image is the image that was selected from the heads-up display, so that's image, and the render position is the render position that we're taking from the world that is associated with these grid coordinates, so that's render pos here. So now we should have a temporary tile if the user has selected one from the HUD. To draw this in our game, we can go to the draw method of the world, and we can say if self.tempTile is not none, so similar logic to the selected tile, we can extract the render position. So I'm going to say render pos equals self.tempTile render pos, and we can do screen.blit. The first argument is going to be the image we want to blit, and that's contained within tempTile image. And now we need to pass the coordinate position where we want to render it. So we're going to be using this render pos, but we have to apply a bit of correction for the camera scroll and the offset. So the x coordinate is going to be the first element of render pos. We need to apply the same offset as we're applying to every other tile. So we're going to copy this here, and we're also going to do the same with apply the same camera scroll. So that's camera scroll.x here. And then for the y, similar thing, but we don't need an offset. Whoops. But we do need the y value of the camera scroll. So this is going to be camera.scroll.y. Actually, one thing that we have to do is some of these images will have more height than the isometric polygons, so we have to apply the same correction that we applied here. So I'm going to copy and paste this code, but we just need to exchange this for the temp tile image. So that goes temp tile and then image. Then we can apply this the stuff that we've changed into our game class. So going to the game class, going down to the update method, because this is where we want the world to update each time the game updates. So after the HUD updates, we can say self.world.update, and we have to pass it the camera class. We made no other changes to the draw method, so if we run the game now, and moving towards the world, and selecting a random object to place, we can see that now, instead of freely moving with the mouse, it's all the object we want to place is always positioned on top of the tiles. So this is what we want. So now we can get a better idea of how the game will look when we place tiles. So that's good, that's worked. The next thing for us to do is to apply conditions such that we cannot place tiles outside of the world grid or whilst the mouse is on top of a panel. One of the conditions that we want to check is whether our mouse is on top of one of the heads-up display panels, because we don't want to build when that is the case. So going to the HUD class, what we're going to do is give each of these panels, these surfaces, a rect object so that we can test for collision with our mouse. So I'm going to say self.resources rect equals self.resources surface.get rectangle, and we want to position this where it is, and we can find these positions down here. So the resources one was just at the top left of the screen. I'm going to do a very similar thing for the build surface and the select surface. So self.build rect equals self.build surface.get rect top left equals, and let's go find the coordinate position of this, and that's here. And then finally the same thing with the select surface. So select rect equals pg, oops, no it's not, self.select surface.get rectangle top left equals, let's go grab these coordinates, there we go. So returning to the world class, we're going to make a small method for just querying whether we're able to place a tile. I'm going to say this new method is called define can place tile, and we need to pass it the grid position because this is what we're going to use to query. The first condition we want to say is the mouse on the panel. So if I initialize this as false, then I can say for rect in each of the rectangles that we've made. So the first one is the resources one, the second one was the building one, and lastly we had the select one. then we can say if rect.collide point with the mouse, so pg.mouse.getPos. If the mouse is colliding with one of these rectangles, then we can say mouse on panel equals true. Then the other condition that we want to meet is whether the grid position that we're currently at is within the world boundaries. So I'm going to define this as world bounds equals, firstly checking whether the x position. So we can do, is the x greater than or equal to 0? And also less than or equal to the grid length of the world. And then do the same thing for the y. But using grid length of y. Okay, so these are our two kind of logical conditions that we need to satisfy if we want to be able to place a tile. So I'm going to say if world bounds and not mouse on panel. So if we're within the world bounds but our mouse is not on one of the heads-up display panels, then we're going to return true, so meaning we can place a tile. Otherwise, if one of those conditions is not met, then we're going to say return false. So moving back to our update method, we can fit in this logic here. So after we've calculated the grid position of the mouse, we only want to do any of this stuff if we're actually able to place this tile in this position. So here we can say if self.canPlaceTile gridPos. If this is true, then we're able to follow the rest of this logic. And actually we'll need to define self.tempTile to be none at the start of every update, and then if it's not true, then we can fall into this logic. To test what we've done, we can go back to main and run our game again. And what we're looking for is that we shouldn't be able to see the tile if either we're on top of a panel like this, or if we move out of the world. So that's worked fine. Good. The next condition that we want to meet is whether an object already exists on the tile which we want to place this new object. So to do this, we're going to go to the world class and we're going to extend this tiles dictionary to say whether an object exists in this location or not. So I'm going to call this new element collision, and we're going to define it as being false if the tile kind of name is an empty string indicating nothing exists there. Otherwise, this is going to be true. Then what we're going to do is add this logic also to the temporary tile. So we can copy and paste this, but extract the collision logic. And another thing we're going to do as a sort of more visual aspect is draw one of these isometric polygons in white if an object doesn't exist in the location, or red if it does, indicating whether we can or can't place the object. So I'm also going to extract the isopoly. Again, copying and pasting this, taking the isopoly element and adding both of these things into our temp tile. So that's isopoly and collision. Now, moving to the draw logic and where we're drawing this temp tile. First I'm going to extract the isopoly. So from temp tile, taking the isopoly element, we need to correct the render position of this isopoly, just like we do with everything else. So iterating through the x and y of this polygon, gonna copy and paste, and then Y is just plus the camera skull for XY, whoops, out here for XY in iso poly. Then we can say if self.tempTile collision is true, as in there an object exists, then we're going to draw a red polygon. So drawing this to the screen, this is going to be red. We're going to use this iso poly object and give it a width of 3. Otherwise, if there is no collision, if there is no object on this tile, then we can draw a white polygon. So like this. Now running the game to see if this has worked. So navigating over here, selecting one of our tiles, we can see this white polygon, this isometric polygon where there's free space, but if we move over top of an object, then there's an indicator saying no, we're not allowed to place the tile here. Now finally, after all of that logic for checking all of these conditions, we can finally start writing the logic for placing tiles in the world. To do this, we're going to go to the update method. We're going to be placing objects in the world by clicking, so we're going to extract the mouse action, so that's pg.mouse.getPressed. Then down here, after we've defined the temp tile, we're going to say if mouse action 0, so if we left click, and also we're going to check whether an object exists in this tile, and not collision we're looking for. Then what we're going to do is we're going to change the self.world object. So if we've clicked, then we can say the new tile in this grid position is equal to the tile that we selected from the heads-up display, and the element we're looking for here is name. We also need to adjust the collision element. So previously it was false, but we need to now make it true because we've added an object there. So that's true. And once we've placed the tile, we want to reset the selected tile from the heads-up display. So we can do self.hud.selected tile equals none. The last thing we need to do is just make sure that the names from the selected tile match all the images that we've loaded into this world class. So I'm going to go over to HUD. I'm going to grab all this logic, move back into the world, and almost replace what we have here in load images, but just keeping this block, because that was one of the things that we didn't have in the HUD. I'm going to apply these convert alphas to all of these images, and now we should be good to go. Oh, I do need to add block here. So let's block. There we go. Okay, now running the game again, hopefully for a last time. Moving across to our world, selecting an object from the HUD, clicking, and placing in the world. Finally, we got there. Okay, great. That took a long time, but we got there.